The pictures on the bottom left show the diffraction and interference pattern produced by double slit experiment with identical slit width. When one of the slit is covered, we get the pattern like top left picture. The graphic on the right shows how the patterns from both slits combine. Babinet's principle states that the diffraction pattern from an opaque body is identical to that from a hole of the same size and shape except for the overall forward beam intensity. Hence the diffraction and interference pattern produced by single slit and double slit experiment should be identical to single wire and double wire experiment, respectively. This is the aperture we are going to use in the experiment this time. On the left, we have a thin wire, while on the right we have two thin wires next to each other with almost no space in between. And this is the laser pointer we are going to use as the light source. Due to a defect, the laser beam doesn't produce a circular spot on the wall. It's elongated in one direction. But it can still be used in our experiment by simply orienting it vertically, so the diffracted light won't be interfered by the elongated light spot. Now we'll start the experiment with the single thin wire. What we get is similar to the pattern produced by a single slit experiment, where the central bright fringe is twice as wide as the others. But now we can also find the bright spot from original laser beam, which is unobstructed by the wire. Next, we use the double thin wire. Those wires are touching each other, at least at the top and bottom ends, where they are attached to the paper frame. The result on the wall is similar to what we got previously. But if we take a closer look, we can find faint dark fringes dividing the bright fringes. Next, we'll increase the gap between the wires. It can be done using a needle to spread them at top and bottom ends. Now let's see what we get from the separated double thin wire aperture. This time the dark fringes are more obvious. It's like the pattern produced by a single wire has been divided into smaller fringes.